All right, hello, Geometry Honors. So today is day 3, I believe, of simplifying radicals, and we're all of my classes are in a little bit of a different place. So if these notes start after where your notes finish, then you may need to visit one of the previous videos to make sure you get all the content. So I've been recording every hour, 7th hour. And so 7th hour left off, we left off where we had realized that, well, because radicals are closely related to multiplication and division, we could go ahead and split things up. You can split up the 81 over 100, simplify that. You can also split this up and simplify those separately and go from there. So we did some examples like that. Well, we're going to expand upon that, and we're going to realize that you can also, if they are already split up, you can join them together. So it says you can also state that for multiplication, square root a times square root b is equal to square root of a times b. So this next rule says that you can only multiply or divide numbers that are either both under the radical or both outside of the radical. So for example, 3 square root 6 times 2 square root 8. They're all multiplying. This is 3 times square root 6. This is 2 times square root 8. So what you can do is you can simplify what's on the same level. So 3 and 2 are just plain old numbers. They'll multiply together to make 6. But then interestingly enough, you can also multiply radicals as long as they're the same index. These are square roots. And since they're both square roots, you can simplify it and make it square root of 6 times 8, which is 48. And then from there, you're always still going to want to simplify the radical. So what goes into 48? Well, we could do, we just did 6 times 8, so we could do that. 8's 4 times 2, 2 times 2. 6 is 2 times 3. And then if you remember when we simplify, we look for pairs. Looks like we've got a pair of 2's. Oh, we got another pair of 2's, don't we? Another pair of 2's. So that means a 2 is going to come out. Another 2 is going to join it. And then what was already waiting for us? The 6 was already waiting. So those are all going to multiply. And then we got a lonely little 3 that's left over. And so our final answer is going to be 24 square root 3. Now that's the way I decided to break it up. You may have been pretty clever and realized that 48 is 3 times 16. And in which case you would have a perfect square. And the square root of 16 is 4. So anyway, there's quicker ways you could do it depending on how you decide to break it down. Well, this next one, I always want you to see if you can simplify with division or multiplication first. 8 divided by 4 is 2. Square root 50 divided by square root 10. They're both square roots. You can divide them. It'll be square root of 5. And you are done. And then let's move on to the next one. Let's take a look. Remember that fraction or division bars act as a grouping symbol. What I mean by that is, let's simplify this numerator first. 4 times 6 will simplify to make 24. And then 6 times 8 is 48. And then we still have on the bottom here, we've got 9 over square root 12. We can go ahead and divide these. Now, 24 over 9 doesn't divide cleanly, but it does reduce. 24 over 9, I believe 3 is a factor of both of those. So we could write that as 8/3. And I'll just leave it out front like that. I'll leave it like a leading coefficient. And then we'll divide 48 by 12. and get square root 4. So I decided to write it this way, where you've got like a leading coefficient and then square root 4 is down on the line. I should mention you could also write this as 8 square root 4 over 3 and kind of keep it grouped like that. 8 is in the numerator, 3 is in the denominator, move 4 in the numerator. That's equivalent. So you can also write it that way. I just don't want you to be caught off guard if you see it written a different way. Now here's the thing, are we done? Is this completely simplified? The answer is no. 4 is a perfect square, so the square root of 4 is 2. So then we're going to do 8/3 times 2, which would get us 16/3, or you could get a mixed number of 5 1/3. 5 1/3. But I kind of like the improper fraction. Okay, so multiplication and division are closely related to radicals. Let's move on over. It says, recall that for multiplication and division, you can split it into, oh, whoops, let me slide that down. Sorry about that. You can split it into the product or quotient of two radicals, and they give us little some examples right there. However, for addition and subtraction, this does not hold true. Square root of a plus b is not equal to square root of a plus square root of b. It says you can plug in some values to see that this is false. So you can grab a calculator and do square root of 9 plus square root of 9 plus 16. And, I'm sorry, square root of the quantity 9 plus 16. That's square root of 25, which is 5. But if you enter square root of 9 into your calculator, or actually you just simplify it on your own, right? It's perfect square. That's 3 plus square root of 16, that's 4. You're going to get 7 as an answer. And notice these are not equivalent, okay? And the reason why is addition and subtraction are not closely related to radicals. Multiplication and division are, but not addition and subtraction. So what you're left doing, the most you can do is you can combine like terms. So it says, for rule 3 here, can only add or subtract radicals that have the same radicands. And it says it's sort of like adding like terms. For example, 3x plus 5x equals 8x, combining like terms. If you're adding radicals, this problem might look like 3 square root 2's plus 5 square root 2's gets you 8 square root 2's. Notice with adding, your radicand will not change. They have to be the same, and you just add the leading coefficients. So let's take a look at an example here. We've got 4 square root 2 plus 7 square root 2 plus 6 square root 3. I always like to check whenever I'm adding or subtracting just to make sure that these radicals are simplified, because sometimes they may not match, they may not be like terms, but if you reduce it, they will be. So I like to check. These are all reduced already. Do we have any like radicals? We sure do. We've got 4 square root 2's and 7 square root 2's, so we've got 11 square root 2's. This square root 3, that's different. That is not a like radical, so it just sits there like so. Now this is really difficult for people. You so badly want to reduce things more and more until you get a nice answer. You're not allowed to. If they're not like radicals, it is not going to be possible to reduce it further. Now, here's the thing I should mention right now. This is an exact answer. Sometimes you don't want an exact answer. Maybe you're measuring a board length and somehow your board length comes out like this. If you're going to have to cut that board, you're going to change these to decimals and get a decimal answer like 25.3. You're going to have to round it, but you round it, and then you can slice that board and you'll be pretty darn close, right? But in math, we often want to be exact. And the reason why is if we have to use this data further, these calculations further, we don't want to introduce an error. We want to have exact answers. Okay, so now take a look at our next example here, 3 square root 2 plus 8 square root 8. So it looks like they're not like radicals, so we're probably done, except for the fact that 8 reduces, doesn't it? Square root of 4 is 2. So what we're going to have is, we're going to have a 2 square root 2 coming when we reduce that 8. But there was an 8 waiting on the outside. And we've got that 3 square root 2 as well. So what we actually have here, once we reduce the square root of 8, is we're going to have 3 square root 2 plus 16 square root 2, which together will be how many square root 2's? 18, that's how many. All right, so we'll call it quits there today. You're going to get another handout today. We'll have 3. I think we're going to save one of the handouts, or I might go ahead and give you both handouts today. I don't know. We'll see. But we'll save a little bit for our last day of learning about radicals. And yeah, so practice these, ask questions when you got them. Have a great day.